a heat exchanger for cooling a hot hydrocarbon. It is a heat exchanger problem. It is cooling of hydrocarbon used 10,000 kg per hour of cooling water, which enters the exchanger at 21 degrees centigrade. Water enters at 21 degrees centigrade. Hot oil at the rate of 5,000 kg per hour enters at 150 degrees centigrade and leaves at 65 degrees centigrade and has an average heat capacity of 2.51. Calculate the outlet temperature of water. Okay, this is heat exchanger problem. Heat exchanger problem. Okay, so in next semester, next year you will study heat transfer subject. There you will have these heat exchanger problems. But here also you can do this problem using CPM calculation and Q calculation. So briefly we will discuss what is meant by a heat exchanger, because that knowledge is required to solve this problem. So heat exchanger exchanges heat between hot fluid and cold fluid. For example, here suppose here hot fluid is flowing and here cold fluid is flowing. Okay, then heat transfer takes place from hot fluid to cold fluid. So here this is cold fluid. Okay, then this is entering temperature of hot fluid. Hot fluid is entering at THA. H indicates hot, A indicates entering temperature, and hot fluid is leaving at THB. And cold fluid, T, C indicates cold, A indicates entering. So this leaves it TCB. Okay, like that you will have 4 temperatures. That is entering temperature. First we should have little bit knowledge of heat exchanger, then only we can solve this problem. Entering temperature of hot fluid is equal to THA, and leaving temperature of hot fluid equal to THB. Then entering temperature of cold fluid equal to TCA. Then leaving temperature of cold fluid equal to TCB. Okay, so here what happens is hot fluid loses heat, then cold fluid gains that heat. Okay, so hot fluid temperature falls down and the cold fluid temperature will increase. Here what is given? Hot fluid is entering at hot oil. Here first we will write hot fluid. Which fluid? Hot fluid is which one? Oil. And the cold fluid is which one? Water. Okay, first we will write this. Hot fluid is oil and cold fluid is water. So oil loses water, loses heat, water gains heat. So here what is entering temperature of oil? 150. So here it is 150 degrees centigrade. Then THB, it leaves it what temperature? 65 degrees centigrade. Okay. Then TCA, water enters the exchanger at 21 degrees centigrade. And your question is, what is the outlet temperature of water? Okay. For this, we write the energy balance, and first we will write the other information that is given here. This is what hot hydrocarbon used 10,000 kg per hour of cooling water. Okay, and here hot oil mass flow rate is 5000. So another 2 points are given here. Mass flow rate of oil is equal to m dot h. Mass flow rate we represent by m dot. Oil is hot fluid. So write m dot h. And mass flow rate of water is m dot. Water is a cold fluid, so it is m dot c. So how much is m dot h? Water enters at the rate, oil enters at the rate of 5000. So this is 5000 kg per hour, and this is 10,000 kg per hour. Okay, and one more thing is given. This oil, average heat capacity of oil, that is specific heat only. This is per kg. So specific heat capacity. Average means you can say mean also here, because only one value is given directly. Mean heat capacity of oil is equal to 2.51 kilojoules per kg per Kelvin. So this is nothing but CP, H, hot fluid heat capacity. Okay, that is hot fluid heat capacity, CP, H. Next, let mean heat capacity of water. It is not given. Heat capacity of water is not given. When it is not given, we know water properties, we know. Because water is cold fluid, you should represent by CPC equal to 4.18. Same units, kilojoules per kg per Kelvin. Okay, you can assume 4.184 you can take. Okay, this is the data. We wrote all the data that is given. Once again, we will see the heat exchanger here. Heat exchanger exchanges heat from hot fluid to cold fluid. Hot fluid is entering at THA, leaving at THB. Cold fluid entering at TCA, leaving at TCB. Okay. So the mean heat capacity in this range THA to THB, CPH is given. Cold fluid CPC is also given, and 3 out temperatures are given. You need to calculate TCB. For this, what equation is preferable here is we need to write energy balance. Energy balance for a heat exchanger. Energy balance for a heat exchanger. Heat lost by hot fluid, is equal to heat gained by cold fluid. Okay, this is the energy balance we need to use to work out this problem. So is it nothing but what? Q only. Till now we have calculated Q in so many problems. Heat lost by hot fluid is nothing but QH, and heat gained by cold fluid is nothing but QC. So this Q and this Q we should equate. This TCB will be unknown. So what is QH here? M dot H CPH into THB THA minus THB. THA is higher. Is this QH? Isn't it? This is what? QH is equal to M dot C CPC into TCB minus TCA. This is what? QC. Okay. So this is the equation we use to calculate calculate. Our unknown is TCB. TCB is our calculation. Okay, we know M dot H, M dot C, THA, THB, TCA, everything we know except TCB. So substitute all those values and calculate TCB. Here 5000 into 2.51 into 150 minus 65 is equal to 10,000 into 4.184 into TCB minus 21. Here also you are adding 273 plus 273 gets cancelled. So here you add 273, you will get TCB in Kelvin. Okay. So from this you will get TCB value as 319.5 Kelvin. This is how to calculate the outlet temperature. What is TCB? Outlet temperature of water. Okay. This is how to calculate the TCB by writing material balance. Heat lost by hot fluid equal to heat gained by cold fluid. Heat lost or heat gained we can calculate using mCp dt. mCp dt for hot fluid, mCp dt for the cold fluid. Thank you.